This statement might be too obvious, but the part of this video is to really prove this statement where we apply the algebraic properties of real numbers so that we can have enough practice and preparation in understanding concepts on real analysis. So we need to show or prove that the product of A and 0 is equal to 0 for all A element of real numbers. This is one of those statements which are very obvious, just like the product of -1 and -1 previously discussed being equal to 1. This is also very obvious, but again, we need to show the proof of this using the algebraic properties of R. Okay, so we are going to look into this proof starting here. So please bear with me. We are going to show this. Now, how do we show this proof? Of course, let's start by letting A be an element of real numbers so that we can apply necessary properties of algebraic properties of real numbers because we have declared already that A is element of real number. The next part here is to make sure that from this portion, the left-hand side, we will reach 0. Okay? Let's try this proof here. Then, we will start with A times 0 as we will actually look into the possible application of algebraic properties leading to what is 0 here. Now, even if it's too obvious again, let us try to just use the algebraic properties. Let's say we have here A times 0 plus 0. Okay, I'm introducing 0 here, this one, not this 0, because 0 is considered as the additive identity, or the identity element for addition. And with that, I can reintroduce a sum of two additive inverses. Therefore, I have here A times 0 plus I can introduce A plus negative A at this point. Okay? So once I introduce that, take note that these two are just opposites or additive inverses. Hence, when you add them, that's just equal to 0. So we are just changing the actual value of the left-hand side. We're just adding 0 and then letting it be equivalent to A plus negative A. Okay. So what we need to do here is to use our regrouping here, or associative property for addition, as I will regroup A times 0 plus A, the first and the second terms, and you will have here minus A at this point. Okay? Now, again, we are doing the associativity here to make sure that we can pair this here. Now, take it, our goal should be 0, and this is very long now. It should be understood automatically that A times 0 is 0, but then again, we are trying to use algebraic properties here. Now, what I would like you to do here is, take note we have A and A at this point. That means we have common coefficients on our two terms, so therefore we can use the reverse operation on one of the properties for real numbers, which we call distributive property. Hence, if we are going to take out A, we will have here, once we factor A, we have 0 plus, once we factor A here, automatically it has 1 here. Okay, so we've used the reverse property of the distributive property. Of course, when you're going to multiply it like that, it will return to this form. We're just doing this because what will happen next, or of course you will have minus A here, because what will happen next is you have here 0 plus 1, which is just equal to 1. So you will have A times 1 plus negative A, which actually give us A times 1 is just A plus negative A here. And what we can see is again another set of inverses, additive inverses. Same as this, as we add earlier, will result to 0. As we add this 2, it will also result to 0. This is the longer proof why we say that this left-hand side, thus A times 0 is equal to this right-hand side, which is 0. Again, even if this is too obvious, but this is how we show its proof using the algebraic properties of real numbers. And this ends the proof. Thank you very much for watching.